All right, so welcome back to everybody. And for those that we are only seeing for the first time, we will be having class every day for the next week or so. I just have to verify on the times so that we all know when it is. I will post the times on Google Classroom because I'm also having another class with the grade 9s, so I don't want them to be clashes. Classes will only be about 45 minutes to an hour. We try to stick to our classes at maximum. I said before that we will be recording the sessions, but it will be difficult to upload the recordings unless I am in the office at NAST and I use their unlimited free Wi-Fi there. Then I will upload the lessons onto Google Classroom as well, and then you can also get it from there. Before I start this lesson, I just want to quickly do a short demonstration of the apps that you will need on your mobile phone if you are using your mobile phone or a tab for the lessons. Okay, so I'm using an emulator here. It's going to be using an Android phone. Just waiting for it to load up. All right, so please take note of the following. I made it like this so that at least you see it's Google Play. It's like a phone. These are all the apps that we have. So the first one is your Google Classroom. This is the one where we will do most of the posting and interacting with. Once you load your classroom, you will see the classes you are with. So you are currently in grade 11, and the stream is just where we posted today's classes as well. And then classwork is where you will find everything. Okay. So all the topics that we have uploaded most of them that we have done, and we will try to go through all of them step by step. Right, sorry about that. There was a call from South Africa. Okay, so after the classroom, I would prefer this to Adobe PF and Adobe Scan. These are the two most important ones that you should have. First with Adobe PF, this one allows you to read PDF files, which I'm uploading on the Google Classroom. As you can see, this was a textbook example that we have from the textbook. So if there's other examples that we can have, we can upload it in this format and you can read it. All right, this is now from your phone. You can use this app on your phone to read it from your phone. And it also has the option that we can edit over here. All right, this option here, edit, you can either use the fill and sign, or you can use the comment. Right, so the comment gives you an option of having a pen, and you can change the pen colors. This is what I'm also going to be using. All right, so once we change the pen colors, we can now start writing on the paper itself. Okay, so that's how we now use this Adobe PF. So whatever I upload on Google Classroom, you can now use your, hopefully your fingers, or I'm using those sensitive touch pens. Okay, and you can also now write on it with that pen depending what you want to do. So that is an example that I'm giving you. And then the other one, so this is the Adobe Reader or Adobe Acrobat. That's the PDF reader. Very useful to have on your phone. You will need it in future or anything else where you have, right? You can also put in texts. Text is now, if you have specific questions, you can type in what is the question and so forth. So that is Adobe PDF. This is now on the homework. If you want to directly answer on the paper, or if there are question papers that we will upload, then you can answer on the question paper yourself. The other one is Adobe Scan. They are from the same company. They look the same. One is red, one is blue. The Adobe Scan allows us to capture pictures, images of things that are outside of the computer. It will ask you for your camera, or you upload a photo or image. So if you have work that you have done on pen and paper, you can now upload it. You can upload it through this one, and then it will go to your classroom. I'm just using an example here. Okay. So if you write on pen or paper, you take a picture, it will take a picture for you and you can upload it, right? Just give it a name. It will always ask you what is the name that you want to give it. So once you give it a name and it is upload, you click on Save PDF. I'm just quickly showing a short demonstration. Okay, it says, just saying fine, but it wants me now to comment on things. I don't want to comment on.
Computer teacher and physical science teacher.
Once you have uploaded your document, all right, there's many examples here that I can use. It will take note of everything that you have. I just want to open this one quickly so that you can see. This one is one homework that has been done in pen. I just want to show you how it looks like. This is now pen and paper, right? So you write in pen and paper on your answer, all your methods. You take a picture with your phone. And once you take a picture with your phone using that app, it will allow you to share. So once you share, you say share a copy, and you can see your Google Classroom is automatically picked up. So you will see that it says Classroom Google. Yes, that's where I want to share it with. And then it will ask you, okay, are you sharing homework? Are you sharing assignment material? What are you sharing it with? Because it will say, oh, this is the classroom that we have. I'm explaining how to use your phone to answer the questions that we will be posting on Google Classroom. We are not sure if the country will ever open, but we are sure that exams must be written in one way or another. So even if you are writing your exams online, this is what you will need. Very important. So if there is a chance that you will write your exams online, you will need these apps. So I'm already giving you that short demonstration now so that you can see how you can use it. So the exams will be timed normally, and if you don't upload in that specific amount of time, you will lose your marks. So those are now things that we are now already getting you ahead of. So over here, you will, because I'm a teacher, it's giving me these options, but when you are a learner, it will say your homework one, homework where, and then you just select where the homework was that you need to upload these things, and it will automatically put the information up there. All right. I can give you an example of one of our students who did the homework. Let me just go to homework. Yes, so over here you can see Loida already did the homework, and she uploaded her homework that she did over there, and we could also communicate here correctly what we need to do. So that is the way that we are now using our lessons and teaching, and she can see she wrote down answers on there, also using this edit comments and things like that. So I'm also showing you here, if in case we need to now edit something, all right? I can now also mark this, all right? I can also already mark this on the paper itself, and then I can now send it through. If I finish the marking, I will now send it through to her and just click on save here, and everything is done. So everything is going digitally. So I'm just showing you an example. This is now from Loide's work. And this is using the phone. This is not using a computer. I just put the phone on the computer screen so that you can see how things are going on, right? So that is now for the work. Loide, this is the homework. That was the worksheet that she completed, and we will also discuss the worksheet a little bit later on. So again, if I repeat for those who are joining, the apps that you need on your phone: Classroom, Google Classroom, Adobe Scan, and Acrobat, Adobe Reader or PDF Reader. Those are the 3 ones, and they are very small. They are less than your WhatsApp or games space. They don't take up space. They are very small, and it's very useful, and your teaching can continue. That is it from my side. Proceeding with the lesson that we have, we said that we will be continuing with this and then explaining the worksheet, because there was a lot of question on the worksheet. How do we answer some of the things that we have? Here last time we stopped with reflection, and we had to start with rotation today. And that is basically where we are continuing. If you have any questions, please feel free to also type it in the chat or raise your hand, and we will answer them. So I will try and keep track of the chat as well and everything like that. So let's get started. We are looking at rotation today. Please confirm you can see my screen. Can you see my screen?
Yes, sir.
Okay, so we are continuing with transformations, and rotation is the next one. You need to be able to rotate the shape about a given point, all right? Normally, the title here and the image here already tells you how we should be able to do it. We have 2 forms of rotations. We can either go clockwise or we can go anti-clockwise. Clockwise is in this direction, anti-clockwise is in the other direction. And we also have various forms of rotations where we have 90-degree rotation, we have 180-degree rotation, we have 270 degrees, and then we have a revolution, but the revolution will just be the same shape at the same position. Okay. So this is referred to quarter, half, or 3/4 turn. Those are the key points rotation that we have. A piece of tracing paper. This is normally the topic where tracing paper can be used or is allowed to be used, and it can also make things easier in the exam. But we will solve this without using tracing paper. That means we will basically show all our workings in solving it. All right. If you use tracing paper, it's just to assist. It's not to show the working. Okay. So over here, we have some steps of how we use the tracing paper. So we will mark the center of rotation and draw a straight line that connects it to one corner of the shape. As you can see also over here, center of rotation, we mark it, draw a line connecting to one point of the shape, which is either there over here. It doesn't matter which part you use. All right. Then put tracing paper over both of the shapes, and then the center of rotation, trace the shape at the line onto the paper. I think this was now practical example we could have done in the class. However, I don't have a way of showing tracing paper on the computer here, so it's a bit tricky. But these are the steps that you need to do when you're using trace paper. So the pencil will be stuck here at the center point as well, and then you draw in the shape, and then after that we will just move the paper, but the pencil is in place holding the trace paper onto the original paper, and then we move it around. That will be the way of rotating. After we reach a certain degree, 90 degrees, 180 or 270, then we mark the corners of the shape, and then we just draw the lines on the original paper. Okay, so over here we are just trying to give you a a short demonstration of how the tracing paper would have looked like. It's a PowerPoint presentation, so most of the images, we kept them stuck inside there. So over here, we have shape A, right? And shape A has been marked a center of rotation, which is the center point where X equals to 0 and Y equals to 0. And then we basically draw the line to the shape, and then we mark also the points of the line. We go all the way around. We redraw the shape on the tracing paper. And once we redraw the shape on the tracing paper, we rotate it. Okay. And once we rotate it, then we draw again the shape over there. Right. So that is basically what we have here. I will just highlight key factors. In rotation, what is always important is the center of rotation, which is a given coordinate. Sometimes we will ask you to find the center of rotation. Okay, so that means you have to find the coordinate. All right, once this is found, then rotation becomes quite simple. The shape remains the same, except that the points are facing in different directions. All right. And here is another example again. We have shape D, and we have a point here, which is the center of rotation. Please note that the center of rotation here is 2 minus 1. Okay, so the center of rotation here is 2 minus 1. So we get the center of rotation, you mark it, that is your center. Then we will take our ruler, join that point to the center. And once that point is at the center, then tracing paper will be used. And once the tracing paper is used, we will now just rotate it on the tracing paper. Okay, so this example again, please note that the triangles here are also referring to some of the tracing paper that we have, and the center of rotation is in one of the shapes. And that is now where it becomes a little bit tricky. So when the center is in one of the shapes, we also need to figure out how can we now rotate the shape correctly. So this point would have remained stationary on the paper, and the tracing paper then is just the one that we move at a certain angle. All right. So let's just see how that one works. So sometimes the center of rotation can be inside the shape. Okay, try rotating the shape F clockwise through a 90-degree angle, and that is basically how we have here. So I've put this things here. We still follow the rules. We will join one end to the center, and once we join that end to the center, we will now also use our protractor, and from the protractor to measure 90 degrees where it will be from there to here, and then that's how we will rotate our shape as well. So most of these things is practical side, so you need your mathematical set to answer these questions and to make it easier for you as well. We move on to enlargement. For enlargement, you'll need to be able to enlarge a shape about a given degree or scalar quantity. That is normally what we say. We normally call this a scale factor. And enlargement is not only making big, it's also making small. So we have increased enlargement and we have decreased enlargement, right? So one is to make big, the other one is to make small. So you need to know how to do both of them. So enlargement, we also have a center of enlargement. Like in the previous one, we had a center of rotation. So center of enlargement is that last point where the whole shape becomes a dot. So it's also something that you need to find. If the scale factor is more than 1, the shape will get bigger. If the scale factor is less, all right, the shape will become smaller, right? A scale factor of 3 will result in the shape with 3 times as large or as long as the original size. If the scale factor is less than 1, the shape will get smaller, but it is still called enlargement. That is what I said previously, right? A scale factor of a half will result in the shape with sides only half as long as before, and so forth. So this is now how we say the difference in the scale factor. All right. We are talking about negative scale factors later on. We will not talk about that one now. a little bit later on. So you will see an example of what we are talking about in terms of a scale factor here. All right. So over here we have a shape called P, a triangle. It can be any shape. Please note it's not only triangles that we will be enlarging. And it says enlarge the shape P about the origins with a scale factor of 2. All right, so what I will do now is I'm going to, instead of writing it like that, I'm going to be now writing in a few things so that we can also see how we can do this without just using the paper and so forth. All right. So over here, we have a scale factor of 2 and we have this shape here. So what we do is we start at a given point of the shape. So I'm starting over there. I write down the coordinates. The coordinates for that point is 1, 1, and 4. Okay. Now this 1 and 4, this is called a row. It's in a row, like a single row. I can also represent it in a column. Right, 1 and 4. This is a column. All right, when we do vectors next, you will understand what I mean by a row vector, and this is a column vector. Please note that this is just the same as saying my X value goes on top and my Y value goes at the bottom, which is the same for this one. All right, if you remember that the first number is always your X, and the second number is always your Y. So how we represent these points is also important. So normally what we do then, after you have your representation of the points, and we like to use the column representation because it's easier to work with, then we basically just now put a 2 in front and just make that a nice one. A 2 in front, and then we will have the 1 and the 4 over here. And basically, we are now saying we are going to enlarge, and that will basically be a form of multiplication that we will do. So 2 times 1 will be 2, and 2 times 4 will give me 8, right? So that will be the new point where we have enlarged it. So if you look at the new point where X is 2, here is 2, and Y is 8, this is the point over there. That is the new point for this shape P, if we enlarge it by a scale factor of 2, all right? So I hope I've explained how we would do it in showing all our working and all our calculating. This that we are doing here is just a way we call vector scalar multiplication. We can also put the 2 outside in the row form. It's not a problem. We can put the 2 outside over here, and then you will just say 2 multiplies the 1, 2 multiplies the 4, like we normally do with our removing the brackets algebra way. All right. So removing the brackets are also used here. Right, and we use a comma to separate X and Y. That's the only thing here that is different, but all the other things are exactly the same. All right, so we can do the same thing by taking another point, all right, and applying the scale factor. So for this point over here, we have, I'm just going to use another color. I used, the first one is done, it's over there. For the second point, we have a X value of 1 and Y value of 1. And remember, this form will be now in transformations and vectors and matrices. We will avoid using this row representation, and we will always go into a column representation. All right. So I'm already introducing column representation over here, and that is how it is. All right. So we will put the 2 outside. We will have the 1s inside. And our final answer will be 2 times 1 is 2, and 2 times 1 is 2. And this is, sorry about that. This is how we represent our enlargement. And then on our Cartesian plane now, you go to where X is 2 and Y is 2. So here's the 2 there, and there's the 2. So they meet right over here. And we do the same for the third one. All right, this is X is 3, Y is 1. So I know it will be 3 times 2, which is 6 over here. And it will be 1 times 2, which is 2. And that is the point that we have. So once you have those 3 points that you have enlarged, the next thing would be for us is just to join all the 3 points together. And then you will have your enlarged shape. All right. Now, this is from a scale factor of 0. Okay. So because the the center of enlargement is 0, we are able to do this. All right. So what does the center of enlargement mean? The center of enlargement only tells us that if you draw a line from this point, join it with where it came from, it must pass through the center that you can see there. This blue line, it's the new point that we have enlarged, passing through the point where we came from, the original shape, and it goes through the center. Same with the other point, this point there, they both go through the center. They meet at the center. Same with this one here. When you draw a line joining it with the center, you will see that this point connects to where it came from and they start at the center. So that is how we get our center of enlargement. Okay. So the center of enlargement is always a coordinate. And when we ask you, we want to find out the coordinate. The scale of enlargement or the enlargement factor, okay, we call it a scale factor. Sometimes you say the enlargement scale, the enlargement factor is this number that we use to enlarge or decrease. So if we multiply 1 by half, it will be reducing the number. That's why it will get smaller. Okay. I hope that is clear from the calculation perspective. And now we will be looking at the slideshow presentation itself. How we will just be representing it in the slide form. Okay. So there's another way where once you have your center of enlargement, you can just draw out the line straightforward. Okay. So without doing the calculations, since I know the center of enlargement is here, I can already just draw out a line. Okay. Like the line goes out this way and another line goes out that way from the center of enlargement, and another line goes out this way. Okay. So I've made them quite big. Okay. So that we can see. So this means that your shape must be within touching all of these different places. Okay, so that's where you know you need to draw your shape in that form. Okay, that's one way of looking at it. Another way would be to follow over here. So draw a line from the center of enlargement, that's a COE, to the vertex, the corner of the shape. Okay, multiply the length of the line by the scale factor. So this is now using that length of the line. So if you know the length of the line, or you know how to calculate the length of the line, then you just multiply it by 2, and then we will get to the other side. But in an essence, we don't need to multiply it by 2 because we know we just need to extend it. It will be on that same line somewhere else there. So here we just multiply that by 2 and then we go on. But if it's by half, it will become a problem multiplying it by half. Then you don't know now. It should be half of the line instead of double the line. We do that the same for the other ones. And we also do that for the last one. And then we draw in our shape. And you can see it's the exact same shape that I drew before using the point. So there's many. Come again?
So it's too fast. We are lost, sir.
Am I too fast? Okay, I will slow down again. But it's Meke.
We are very lost.
Okay, so I hope, okay, please just try to follow. As we said, we are recording this as well. So just try to follow as much as you can, and we will see how we can always get the recordings back to you. All right. So as I've said before, let me just summarize quickly what I've said about the shape over here. All right, we will use this shape over here. And the question says, enlarge the shape Q about the points, this one. All right, let me just break down the question. This will be our center of enlargement, and this will be our scale factor. So we are reducing the size because it's less than 1. So they want a smaller shape, okay? So if we know the scale factor, all right, it will be easy. If we don't know the center of enlargement first, now let's say the center of enlargement was not given to you, all right? This is not there. Then what we will do is we will take a point, any given point that we have over there. We will take all 3 points basically. Normally 2 is enough, but we will take 3 of them, okay? Just to conclude the whole situation. You take a point. This is now also for the previous question. Whatever you do, you always start with a coordinate, a point there. So this coordinate over here has x is 2. So we have 2 and y is 7. Okay, let me write down that coordinate point quickly. The second one is x is 2, y is minus 2. So we have another one. My hand is a little bit sleepy. We have another one where 2 and we have minus 2. And then we have another point over here where x is, if this is 2, 3, 4, 5, 6, 7, 8, where x is 8 and y is minus 2. Okay, so these are the 3 points that we have. And remember the scale factor, you just multiply everything inside by that scale factor. Okay, so this will be 1 over 3 multiplied by 1 over 3. This will be also multiplied by 1 over 3. And this will also be multiplied by 1 over 3. So remember I said that we normally use row columns or row vectors because it's easier to see and there's no comma inside. Okay, so the 1 over 3 will multiply the 2 and the 1 over 3 will multiply the 7, and then we will get our new coordinate. Okay, the 1 over 3 will multiply the 2 and the 1 over 3 will multiply the minus 2, and we will get our new coordinate. Okay, and the 1 over 3 will multiply the 8 and the 1 over 3 will multiply the minus 2, and we will get our new coordinate. So once we get the new coordinates for all of them, I just quickly want to get something. I want to get my calculator, or is there somebody that can calculate for us already? Is there anybody who can calculate what the new coordinates will be? If you have your calculator ready. Okay. So let me just. All right, I just want to calculate quickly what is the first one. So we have 2, it will be 1. 1 over 3 multiplied by 2. That will give us 0.66 or 0.67. Let me also just write that in. So I have 0.667. And the next one will be the same, 1/3 multiplied by 7. And that will give us 2.33. Okay. And the other one will still be the same, 0.6. 67, and then we will get another one minus 67, and then we will get more. Okay, my writing and calculators is not so clear, so let me just quickly go to the other side and do that. Is there anybody who already solved everything?
Okay. Como que? Vou comprar primeiro.
Okay, so I wrote down these numbers here, and I just want to quickly explain what is going on here. Now, in most cases, most of the students normally are going to take this approach. And now there is one problem with this. Now, always note that I always teach you the problem, because I'm telling you where you are already going to make the mistake before you even make the mistake. Because remember I said that we have scratched that the center of enlargement has been taken out, and we just give you a scale factor over here. Now, because we gave you a scale factor over here with no center of enlargement, by default, all of us are assuming in our brains that the center of enlargement will be 0, 0. So these answers that are here are not considering the new center of enlargement. They are only considering that the center of enlargement is the origin, 0, 0. And this is where most of us will get wrong, okay? All right, so that is one way we can do it. But remember, it's not focused on this one. It's focused, if it's on this one, you will get it wrong. If it's on the center of origin, you will get it correct, okay? So this is now where the question will tell you that the assume or that the enlargement center of enlargement is the origin, then this is what we do. If it's not the origin, we do not do it this way, okay? So if it's not the origin, they must give you the center of enlargement, and that is what we will have to do to use, all right? So that is one way that I quickly wanted to explain, and we have seen many students always just go to 0, 0 by default, and they don't focus on this one as well, all right? So let us proceed from here. So with the center of enlargement, we will always indicate it on the paper, okay? And once we have indicated on the paper, all right, then we now know that we have to reduce the size, okay? And this is now how it reduces the size when we have a given coordinate and then gives us our answer, all right? We look at another example quickly. We have the shape